Hey everyone! So, I generally keep up with what's going on in the YouTube tech space, and one thing that caught my eye recently was that some companies aren't even asking for resumes anymore. They want you to post your application to an API, just to prove that you can actually build a working application. I thought this was an interesting concept, so why not do it in Rust? I decided to do this project two ways, once using dependencies, and another time not using any dependencies at all. So let's start with the dependency version. First, I brought in reqwest, which is an HTTP library that's impossible to spell. Rust standard library doesn't include an HTTP client, so this crate makes it a lot easier. The next dependency I brought in was serde, which serializes and deserializes Rust structs to and from JSON. For this app in particular, it just turns the application struct into a JSON string for the request body. And then, when we receive a response from the company's API, we deserialize that JSON response back into an API response struct. And I'm just printing this response to the terminal for now. Then, I brought in Tokio, which is a runtime that allows you to execute asynchronous code. If you've ever watched the Primogen streams, there was a period of time where he was programming in Rust, and he had a very distinct way of pronouncing this that absolutely killed me. So yeah, go check that out. Anyways, the reason I brought in Tokio is because request by default is an async HTTP client. So you'll note here in the code that it's returning a feature, and then there's an await that suspends execution until the network response arrives. That suspension only works if something is pulling the future, so yeah, that's Tokio's job. Same thing for the await a little later on. Technically, though, I could have dropped Tokio entirely from this project and used the blocking version of request because I don't have a ton of concurrent requests going on here at the moment. But let's say I wanted to expand this app to send my resume out to multiple endpoints concurrently, then Tokio is definitely the right tool for that job. As I was setting up these dependencies, I kept thinking about recent issues in the JavaScript universe where NPM is getting completely owned by this thing called typo squatting, meaning that you go to install something via NPM, but you accidentally type a random name instead of your intended dependency name, and boom, you've got malware. Luckily for Rust, Cargo seems a bit more curated than NPM in my opinion, and one thing I learned when wondering about this is that Cargo does not arbitrarily run install time scripts like npm does, although some crates can still include build scripts. Don't get me wrong, you can still get owned with Rust. Rust is not immune, but the risk seems a little bit lower with Cargo than with npm. Also, one thing to note when building with AI is that it will often suggest not the latest versions of every dependency. But if you run cargo add manually for each one, you'll get the latest version of the package. Just make sure to use the features flag if you want something behind a feature gate, such as JSON for the request dependency. So with all that brought in via cargo, let's start to take a closer look at the actual code. Tokio turns our main function into an async function, and the new request client is created. Then I set up our payload by hard coding values to send for each field of the job application. One possible enhancement in the future could be making this part into some sort of UI and have the fields be much more customizable, but for my purposes, this is just fine as a proof of concept for now. The next part is looking for where we are posting our application to, as in what URL, what endpoint. This looks for an environment variable called post URL to see if it's set. Otherwise, it uses the URL hard-coded directly in the application, which for now is definitely not real. So you would have to swap this out to whatever real endpoint you would be posting to. So I created a local test server to receive and print the post request. When looking over the code that was generated though, I noticed that the server had the unwrap function everywhere. And if you're not familiar with the perils of the unwrap function, go check out the Cloudflare issue that happened in November of last year. It was basically a panic caused by an unwrap that took down an entire portion of the internet, because unwrap turns a potentially recoverable error into a hard crash. So I changed this in my server to log connection errors instead of panicking. One thing I noticed when looking over the code was that the status and the response message never actually printed to the terminal on the client side, so I went back and added that in for clarity. Now, the non-dependency version. Why did I do this? Back when I was in finance, some of the top hedge funds hardly used any external dependency in their code. Almost everything was coded in house with a very small, strictly allowed exceptions. I wanted to see if I could achieve cool factor here because I'm sure that companies want you to understand what's actually going on beneath the surface rather than just relying on abstractions all the time. And this was actually one thing that put me off from Python, though I still do use Python to this day. It just initially felt like anytime you had to do something in Python, you imported a library and called it a day without understanding any of the internals. With Rust, the dependency ecosystem is a bit smaller than Python or JavaScript, so I feel like you're more incentivized to think about the problem yourself before immediately reaching for a crate. Turns out overall, it's not too bad to do a no dependency build if, and big if, you are doing HTTP only. So, in order to do HTTPS, which is basically HTTP operating in the land of encryption, then you need some way of hand rolling your own TLS, which is transport layer security. And rolling your own crypto is not exactly recommended. Back when I was in finance, part of my job was securing each fix session with a TLS certificate, and that alone could get a little bit tricky. So, handling your own TLS could be a whole security thing. However, I might do another video sometime doing a Rust implementation of TLS solely for learning purposes. Another thing to point out about the no dependency version is that I went from asynchronous to synchronous. I wasn't really using the benefits of async that much anyway, so this was fine. The app just does a single post per run. In my opinion, the more tedious pain point of going with no dependencies is that JSON encoding and decoding. Doing this by hand can be error prone, especially with the unknown myriad of responses that you might receive from the server. So for my purposes, I just threw the whole TCP stream into a vector and separated the header out from the body before basically just printing the bytes. If you need to pull a particular field out of the response, you'll have to build a parser for that. So yeah, I feel like this was a great learning exercise in building something fairly practical. So as always, the GitHub link is in the description for all of the code, and feel free to leave feedback in the comments. Until next time, bye!